This video is on logarithms and polynomials. When we have an equation of the form a to the power of x equals b, we use a log function to solve for x. And you find that these two here are equivalent. So a to the power of x equals b is equivalent to log base ab equals x. These two are in the AI formula booklet to be able to switch between the two. Note that you can only take logarithms of positive numbers, and the base of a log, so the a value in both of these, can be any positive integer, but in the AISL we are only going to use base 10 and base e, and also b has to be greater than 0. So for log base 10, you write log a little 10 and then b. That is exactly the same as log b. Quite often with logs, if you don't see a base there, it is automatically a 10, just like when something's a power to the power of 1, we don't write the 1, it's just we know it's a 1. Same here, if it's a log, we know the base is 10, if it's not written otherwise. Some of the things just to know that log 10 to the power of x just equals x, and 10 to the power of log x also just equals x. Also on calculators, on your a small Casio calculator, you generally just have a log button, which is always to the base of 10. On your TI Inspires, on your GDCs, the log button does give you the option to put in any base. Or on your GDC, if you put in a log and don't put in a base, it will automatically assign 10 as the base as well. We also look at base e, and e is known as Euler's number, and it's like pi, it's just a random number within math that gets used a lot, and it's approximately 2.718. Now with log to the base eb, as you see here, that is also the same as lnb. So if you look at your calculators, generally next to the log button, you'll see an ln button, and that is for log base e. We just write it this way because it's a lot quicker, and it's much easier to distinguish then between base 10 and base e, which are the two most commonly used logs. And then just some two that to be aware of, that ln of e to the power of x equals x, and e to the power of ln x also just equals x. They are like the inverse of each other, they kind of cancel each other out. Now, just use a calculator to find these. I've already put the answers in, so you just need to make sure you can find these yourself on your calculator. So make sure you can find your calculator buttons on either the small calculator or the GDC, and you get the same answers as the ones here. And same with example 2. With example 2, you need to n-solve it to work it out, but I will show you, say with a and b, you could use that equivalent rule to make it a log, and then you can just put it into any calculator. Let's just write the equivalent rule. So if you've got a to the x equals b, that is equivalent to log a b equals x. So with a here, that means if we have e to the x equals 4 and use this rule, the a is e, so we'd have log to the base e of b, which is 4 equals x, and you can write it that way, or you can write it as ln4 equals x. And if you just put ln4 into your calculator, you would then see you'd also get 1.39, which is the same as using n-solve. And b is the same. With the 10, we change it to a log, so you'd have log, the base is 10, 21 equals x minus 2. And then we can rearrange that, so we'd have log 21 plus 2 equals x. Now remember, I don't need to write the base 10 because it is just a log 10, we don't have to write the 10. And put that into your calculator and you'll get 3.32, or as I said, you can n-solve it. Now on to polynomials. A polynomial is an expression featuring only non-negative powers of x, such as 3x squared minus 4x plus 1, or negative 12x cubed plus x plus 3. The zeros of a polynomial are the values of x for which the equation equals 0, so the x-intercepts. They can also be called the roots of the equation, so you can see any of those words, you could see roots, zeros, or the x-intercepts. Sometimes you can also be asked to solve the equation, which is asking you to find the x values too. There can be several roots of a polynomial. The maximum possible amount is the same as the highest power in the polynomial. Example 1, find the roots of the equation x cubed plus 4x squared equals 5. So the first thing to do in these situations is we need to make the equation equal 0. Once we've done that, we just use our calculator to solve it. So you have two options on the TI Nspire. You can either graph it and then analyze the graph and find the intercepts. And in the analyze graph section, you'll actually see it's called the zeros, and do that. You can find it that way, or you can use the polynomial roots solver on the calculator in the calculator page, and in there you would pick a degree of 3 because the highest powers are 3, and then enter the information and then get your answer that way. And if you to do that, you will find that the roots are x equals negative 3.62, negative 1.38 and 1. They're the three solutions. Be aware in this equation here, you'll see there's no single x. That is fine when you're using the polyroot solver. You would just put in a 1 for the x cubed. You'd put in a 4 for the x squared. For the single x, you would put in 0. And then for the constant, you would put in negative 5. Example 2, given that x satisfies the equation 2x minus 1 and x equals 4, part A, show that 2x squared minus 4x minus 1 equals 0. So we have to use the equation we've been given in the question. 2x minus 1 and x equals 4. And we need to do something with this so it looks like what we've been given in part A. And the first thing we notice is that there is no fraction. So to get rid of the 1 and x, we need to multiply everything by x. And that includes the 4. And by doing that, we'd end up with 2x squared. The x's cancel here, which leaves us with minus 1. And that would equal 4x. And then we just have to rearrange that. So it'd be 2x squared minus 4x minus 1 equals 0. And in part B, find the possible values of x, which just means solve it because our equation equals 0. In part A, so use the polyroot solver or find the x-intercepts on the graph on your calculator, and you would find that x could be negative 0.225 or 2.22, and they're all given to three significant figures are the answers. That's polynomials.